This is the Amp Hour Podcast, recorded December 2nd, 2015. Episode 276, Eating an Elephant. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And this is Michael with Programming Electronics Academy.
And this is Dan from Rheingold Heavy.
Welcome, guys. This is my usual hangout group with these two guys, but Dave couldn't make it tonight, and I wanted to talk about some awesome stuff like getting started in electronics, because that's actually something that Dave and I don't really talk about that much. So, welcome. Michael, oops, geez, just knocked a bunch of crap off my desk. Michael, why don't you tell us a little bit about yourself to start with, and then Dan, you can go after that.
All right. Well, first off, hey, I'm honored to be on the show. I've actually been listening to Amp Hour since like episode 1.
Whoa.
So
sorry.
Yep.
Yeah.
I know. No kidding. But no, I've really enjoyed listening. So my name's Michael. Yeah, give me a second here, Chris. I'm trying to.
Michael lives in my area, actually, as weird as that is. Michael lives nearby.
Yes, I know. That's what it was funny listening to the show. I'm like, because I just found it randomly on iTunes, and I'm listening. I'm like, whoa, this guy's from Cleveland. That's nuts.
Yeah.
So, and then I saw that you guys had the electronics meetup, so that was kind of fun to meet you up there too. But yeah, so my name's Mike, and I've run a website online where I teach people about learning Arduino.
Right, and you used to run a podcast as well. That's the
I did.
Yeah. I was surprised. I didn't know about that for a little while. So
yes, it was the Open Source Hardware Group website. That used to be the name of the company I was running until I just rebranded here recently. So, yeah, and so that's kind of what my angle is. I've been messing around with electronics for about a little bit over a decade. So
awesome, Dan. How about you?
Dan from Rheingold Heavy, and I too have been listening to the Amp Hour for seemingly ages and ages now.
Too long, right?
For too long, exactly. I've been working and playing with electronics now for probably close to 15 years, maybe a little bit longer than that. Really got started when I was working down in Silicon Valley in IT. And you'd go into all the electronics shops and you'd see the guys that were, going through the resistor bins and going through the capacitor bins. And I really wanted to know what it was that they were doing with that stuff. And honestly, there was a little bit of envy in there. Like, I just work in IT, and those are the real technologists. Those are the guys that are working down on the bare metal. and I really, was a little envious of that. I wanted to be that guy. So I started trying to teach myself as best I could, which involved getting as many books out of the library as I could, and taking some classes out of the community college at Mission College down there in Santa Clara. But it never really clicked at the beginning. It was a struggle to really teach that stuff to myself, especially since I was working full time at the time. But you slowly work at it, and you set it down for a couple months, or in some cases a couple of years.
Yep.
And you pick it back up because you read something somewhere and something starts to click, and that's how I sort of got to the point where I am now, where I am self-employed, making circuit boards and writing educational electronics content.
Yeah, and people may remember Dan was also on Embedded a while back.
Yep.
So that was a good show as well. And
you may have also seen me taking the trash out, apparently, at the Hackaday SuperCon a couple of weekends ago.
Dan also works with me part-time on parts I own, stuff like that. So I get to hang out with him a lot. And he was running around with a lot of trash at the Super Conference. What I wanted to talk about today, though, so Michael has a course about getting started with Arduino. Dan does a bunch of great tutorials about I2C and SPI and a bunch of boards that are around that and other educational type boards. Obviously, I run Contextual Electronics. We're kind of all in the same space, and that's why we hang out in the first place. We kind of have regular online meetings, kind of just talking about the space. And the thing that I was mentioned before the show is that you heard these guys say 10, 15 years a piece as well, but it's been a while since all of us have kind of been right at the beginning. But what we do have is we get to see how people we're teaching or working with or who are going through our tutorials, what they're struggling with. And then, there's always the rediscovery, jumping into a new topic. There's always that kind of stuff as well. So, I mean, Michael, I always think of the Arduino kind of as a launch point for a lot of that stuff in the first place. I mean, what are some of the early issues you see when people are getting started? I mean, are they just showing up with, I have no idea about electronics, or where are people coming in?
Right. No, that's a great question, because I know like Arduino is really becoming a de facto entry point for people getting into electronics in a lot of cases. And like you were saying, it's like that curse of knowledge that you get. At some point you just kind of know stuff, and you forget, like you were saying, how difficult it was to kind of get a handle on that information. So to be honest, and this is maybe a little off the wall, but I think a lot of times when you're coming into it, just having the right mindset about approaching something as ginormous as a field of electronics, it can be pretty darn intimidating. So it's like kind of working through that intimidation and being like, what, can I really even get into this in the first place, or is this just above me, period? Because I think some people, or a lot of people, myself included, you might have like preconceived notions about, am I a math person, or am I a programming person, or am I, they for whatever reason, they have these thoughts, beliefs that, maybe this is a little too, I don't know, hard science kind of thing for me. But so I think just working past some of those issues and is something that I see a lot of students have to do. So
yeah, no, I've seen that as well, and it feels like that's kind of the magical thing when people get to the point where they're like, oh, so I could just go try it. It's just,
right.
That is kind of it is a lot of mindset kind of stuff.
Yeah, I mean, I like celebrating failure, basically. I mean, you can't, like, if you approach any type of project, especially a beginner project, with some expectation that, things are going to actually go right, you're often left field, because it so rarely goes right. It's just that consistent determination to, like, what, I'm going to see this through, even though this is so freaking hard. I want to smash my head against the wall, kind of thing.
I mean, and Dan, you said you were coming from IT as well. I've seen some people come in from IT, and I'm not sure. I don't think it's specific to the profession, but I see a lot of people for my course, and just people that are getting started that want to jump into it, that are coming from IT. Is there mindset stuff around that, or is there anything, or is it more just everybody coming from everywhere?
Well, my experience in IT, especially there in the last few years of my work in that field, didn't even really involve technology anymore. It was more, negotiating cell phone contracts and managing, a storage array network. You're not actually doing any engineering anymore. You're managing stuff that was designed at Dell, and you spent tens of thousands or hundreds of thousands of dollars to purchase it, but they put a lot of effort into the interfaces and into the designs. And honestly, electronics has gotten to the point now that in IT, the dirty little secret is that it doesn't really break all that often anymore. Of course, when it does break, it breaks spectacularly.
Right. Yeah. Server room's on fire again.
But yeah, exactly. You get the fire axe failures, where the way something breaks is because somebody went crazy and drove a fire axe into the face of your rack. So from my part, the thing that I grew frustrated with was that there wasn't any real technology anymore. It was helping users uninstall adware from their laptops and and like I said, negotiating cell phone contracts. But that's not engineering anymore. That's not designing networks. That's not building out data centers. That was the stuff I really, really enjoyed. I think there's also a little bit of that sense of you get to touch technology, but you don't get to build with it. If you're working in IT, that I consider IT to be exclusive from software development. So if I'm in IT, I'm supporting the systems that the software developers are using, but I'm not particularly writing any code myself.
Right. Yeah. Right.
Right. And I guess I think like too, IT is such a big field. I imagine there's a whole, it just kind of matters where you fall in there, I would think.
Yeah. And I remember, along the way, there were some people that told me that I should specialize in specific areas like systems management. I should be the guy that knows how to install software remotely across a network. And the idea of being that specialized never really appealed to me. I wanted to be more of the generalist, of being able to see the whole picture about what was going on in the enterprise.
Well, there's interesting parallels now too as well. I mean, like because it is interesting how electronics is moving not to that same level of hands off kind of thing, but it is possible to jump in with not necessarily an Arduino, but maybe like a Raspberry Pi, right? So you can get onto that. You can be in Linux. You can be playing with this piece of electronics, and it can feel like you're doing that kind of thing, but it's still pretty high level. And then it feels like the part that's would be scary for me coming down through those layers of abstraction would be getting to the actual hardware, flipping the bits, building a board to attach onto it, that kind of thing. That feels like that would be like a dead stop for me. It like if it was just living in the software world, got this piece of hardware, just like, okay, now I'm at the physical layer, but now what next?
Oh, but that's the exciting stuff, man. That's flipping the bits.
I agree. I mean, yeah,
and working with registers. I mean, that's where the black magic happens. That's where where I bring the board that I had designed and submitted to OshPark, and I brought that into my coworkers and showed them what I'd built that weekend, and their eyes are wide open. They're like, a person can just do such a thing? Like we're in the 21st century now. Some things actually do exist in the future now that are cool.
Yeah, well, that's like when Michael was talking about too. Like just the mindset of yes, you can do this stuff. That's a big hurdle, regardless of where you're coming from.
Right. Yeah, and and kind of along that line too is kind of along the mindset thing. And you've mentioned it before on the show, Chris, but the expectation now for what you can do is such a high bar. So, for example, I used to teach about a year ago, I was teaching a volunteer program to kids and just electronic stuff, right? And so, I kind of open up the class with, okay, what do you guys want to build, for like the coming months, and it would be like, oh, I want to make an iPhone.
So do I, kids.
I'm like, oh, right. And it's like, yes, you can do some really amazing stuff.
I imagine even better being like, well, here's your ticket to Shenzhen. We got you a great position in a Foxconn factory.
Right. But it's so you can do a lot of amazing things, and if you want to get down into those details, those the registers and everything, it's like I don't know. It's an interesting way to go.
Do any of the people that sign up for your course, do they have that sort of experience already? Do you get most people that are coming in with that sort of like, I've already dabbled in Arduino, but now I want to become the full-on addict?
Right. Actually, a lot of people, I get a huge range of people who come in, but a lot of people are actually like familiar with BASIC. And so they're trying to kind of pick up and understand Arduino a little bit. So I get that. I actually get a lot of really experienced programmers who are just trying to learn the physical side of it, basically. Kind of along the lines you were talking, Dan.
Well, let's talk about that. I mean, someone coming in might be 10, 15 years of doing software stuff, and the hardware, putting a blinky strip on something or controlling a relay for the house, something like that feels there's enough draw there, and Arduino seems like the platform there. Is it so for both of you? I mean, is it start with a project, or is it start right to the board and start building a board? Like where do you always tell people to go?
Well, the hardest thing I always found when I was first learning electronics was that everything was presented to me, at least back then, in the form of theory. You pick up a book on electronics and it was, here's Ohm's law, and then you go straight from Ohm's law to here's Thevenin's
RC
theorem.
circuits, and
you're like, okay,
chapter 1 of our electronics.
Okay, yeah. So now I know what susceptance is, but I still haven't plugged anything into a breadboard.
And Mo's.
So yeah, exactly. If I'm talking to somebody that's interested in this stuff, my recommendation to them is to find a sort of sandbox kit, not something that has a lot of variation and that has a lot of options, but still provides you with a guided path, so that because you don't know what kind of problems you can solve until you understand what your tools can do.
Yeah.
So
recommendations on any specific ones, or?
Well, of course, the I2C and SPI Education Shield.
Of course. Well, seriously though, like, would that be something where you'd think someone would be like, oh, well, I'm just going to go learn a protocol, or is it there's something before that for your stuff?
For my part, I designed that first product, the I2C and SPI Shield, specifically because I didn't want to cover the same basic electronics knowledge that everybody else was covering. Michael is doing a fantastic job of doing that already. Why should I bother trying to compete in that space? That doesn't do me any good. It doesn't do Michael any good. But I wanted to explore the more sort of intermediate to advanced topics, and not just on the surface, but get into them in greater detail. So, but again, it's sort of a tricky business, particularly for me, because you wind up being in this sort of area that if you're going to become an embedded designer or an embedded engineer, you're going to need to know how to analyze an I2C or SPI signal trace. But if you're just building your art installation for Burning Man, you just need to know how to use the library, and you could frankly care less about what the clock signal is.
Right. So kind of like the diving down through the abstraction. Sometimes you don't need to, right? Sometimes it's just use what's out there, buy a thing off the shelf. I know that was one of my big things where it's like, oh, I want to learn FPGAs, but I guess I got to build an FPGA board first. It's like, whoa, Chris. Because then you'll be like 8 months down the line, you'll make no progress. And that whole time I should have been working on flipping a single bit in the software first, and getting that small win, and then kind of moving on. I mean, like, Michael, is it small wins? Is that the thing for you?
Yeah. I mean, I see, like, for me, the appeal is, it's like, I just want to know all things in the universe.
Okay.
What I'm saying is, like,
that's not ambitious.
I'm just really interested in a lot of those details. So, like, and I think a lot of people out there too are interested in those details. They use the library, and they can, get the library running and understand the functions, or they kind of understand the functions. But it's like, I think almost everybody who does it at some level are like, well, what's down below that veil? What's really going on here? And so I think, that more specific information really appeals to that desire that people have to really fully kind of understand how things are going. But it's kind of like you said, Chris, there's just so much, there's just so much knowledge out there. At some point, you just have to kind of choose what you're going to focus on.
Yeah.
And if you can do that, then you can really get deep. And before long, you can, but before long of like getting deep and getting specific on a topic, you find that you know a lot more about it than many other people who decided just to kind of, go with the library and do something else.
Spending the time and learning what's under the hood, that kind of thing. I have like a anecdote about, I remember like before I was in the whole, meeting people at Hackerspace and stuff like that. Well, the first time I went to a Hackerspace ever, I remember meeting someone, and maybe I've mentioned on the show before, but I remember meeting someone, and they had a 3D print. They had a cupcake, like one of the early MakerBots, and they're like, I made this. I'm like, holy crap, you designed that whole thing? You did it? And then night went on, couple beers later, and and then someone mentioned like, no, it's a kit, and I'm like, oh, it's a kit. I can't believe they misrepresented themselves. But then a couple years and some experience later, it's like, yeah, no, like that's still a big deal. Like that, like getting to the point of getting that kit working, or getting, like even starting from the point of a kit, like that not only gives you the experience, it gives you the finished, that is the place to start. And I kind of wish more people would have pushed that on me, instead of me looking at it and being like, oh, I have to learn everything first before I can do anything. It's like, no, sometimes you can just go buy a kit and get started, and then you figure out what your struggles are.
So I know I've talked with you, Chris, that one of the things that I am particularly interested in is building systems for measuring scientific data in the oceans.
Oh yeah, right.
Yep. And I don't. Where do you get started learning that sort of stuff?
I think you know, peel a resistor off like a reel, and then you just drop it in the ocean.
And see
that didn't work.
Yeah,
what next?
And come back 3 months later and see how corroded it is. But and I've been sort of tinkering this over. This was actually my lead into electronics in the first place, was wanting to build some sort of autonomous ocean-going sensing thing that you could just drop in the water. It would drop underwater, sense a bunch of stuff, come back to the surface, and blast that information. Of course, I wanted to do that in like 1998,
and you wanted it to catch a tuna for you too.
Of course.
Well,
I mean, if you're going to be doing electronics in the ocean, you should get fresh sushi out of it while you're doing it.
Right.
Yes.
So this idea, this niggling desire has never gone away. And then I ran across the Open ROV.
Right. Yep.
And I thought, well, what's the point in me trying to figure out how to do this stuff in a vacuum when there's a community of people out there that are already actively engaged in figuring this stuff out for themselves,
Yeah.
And especially if there's a kit, then I can build the kit, I can learn from the kit, and then I can, again, I can figure out what I can solve based on the tools that I've now learned how to use.
There was a best of post today on Reddit, and it was talking about like what it was like before the internet, and it was talking about, oh well, if the person was mentioning like if your family had a medical question, it was like, well, your uncle is a doctor, we'll have to wait till we see him so we can ask him, or we'll have to call him, that kind of thing. And you think about it now, and it's like, no, why would you wait? You just go type it in. But the same kind of thing where now, not only do you have access to that, you have these super concentrated, like the Open ROV, like there's a community there, like that. And there's people that have very recently started dropping electronics into the water, and like, you can go ask them the same questions, and just like the amazing how different it is from 10 years ago kind of thing. Or, well, what was it? I guess 17 years ago for 98, right?
Yeah. Well, one of the classes I took out at Mission College was the electronics calculations class. Mm-hmm. And I thought, oh man, we're really going to get into it now. We're going to be into the nitty gritty of all these different formulas that I've been seeing. And I got into the class, and the teacher literally wrote the keystrokes for your calculator on the whiteboard. He would like draw a little box and then put the number in it, and then draw another little box and put a number in it, and then draw a little box and put the plus sign in it. It was the most stunningly boring class I've ever taken, and coincidentally the only class I ever got 100% in, because how could you not pass that class with 100%?
Right.
But that's not that. In my opinion, that's not how you learn this sort of stuff. You've got to start with the small win. Do something first.
Yeah, I agree. Just if you can just start doing something, kind of get over that, I don't know, that initial fear of like, this is just too much for me, and just try something. And a kit, maybe some people would frown upon a kit, but man, a kit, I think a lot of people started a kit. I mean, I've done plenty of kits. I really kind of enjoy them. So I think you're right there too, Chris.
Yeah, and I think with your stuff, so I've seen Michael's course obviously, but the thing that I actually like about yours is it's not just an exercise, right? So it could just be a servo, but you actually do stuff around it where it's kind of more what's the one you have, like a slot machine or something, like you have an overlay for
Right.
stuff.
Yeah. Right. Yeah. And it's really just so, because, and you're big, I mean, you're big on this too, Chris, but it's like you can't, I feel like, I feel like you really can't teach anybody anything. People can't be taught. They have to learn for themselves.
Ooh,
And
there's a
so it's
strong
like,
assertion for someone that's
I
making
mean,
his living
what-
teaching people.
well, I know, but what I'm saying is
You're
like
all screwed.
this,
Just go do something else.
No. what I'm saying is the student is really got to, they've got to take the onus that the student has to say, I mean, they could be presented the very best information in the world, but to really integrate that information into you know, to have it like in your brain and to be able to use it on a practical level, you have to like use it. You have to do more than like score some answer on a quiz. You know, that's not what this is about. This is about like, okay, so I've learned some information, but can I actually apply it? And so, I mean, to me, that's what is, that's kind of what I'm talking about. So I focus a lot on like challenges, you know, so you have a concept and then you do a practical example to kind of force and stretch yourself to really make sure that do I actually understand it? I mean, and the measure is, can I do this? If I can't do it, then you know what, back to the drawing board. Cause I didn't quite fully understand it.
Do you have a specific structure for your course, Michael? Like what's the entry point? What's the first thing somebody does when they take your course?
Oh, that's a good question. Okay. So I kind of start, and I'm in the process of reshooting a lot of the course right now. I'm kind of coming out with the second edition, but, and I've been doing the course for about 3 years. So I've put a lot of thought into how students move through the course and where people are successful. And a lot of the questions have come up. So I actually start the course right now with talking about mindset a little bit and talking about that, you know what, there's nothing easy about it. There's nothing necessarily simple about it. It's really what approach are you going to take when something's not working right?
Oh, that's good.
And I just, you know,
Could
and
you
that's,
give us a synopsis
and I
of
try
that,
to actually,
or is it kind of pretty in depth?
no, I mean, that's kind of the synopsis. It's basically like, hey, this isn't easy. You know what I mean? But that doesn't mean that you can't do this. It doesn't mean that, so I try to bring, at some point, people are getting into electronics for a reason, right? They sign up for the course for a reason, and maybe they had some like really cool project in mind, right? And they want to build it, or maybe they want to help somebody out with something, and they have this thought in mind. And when they first get in, that thought is all golden and shiny and like kind of exciting. But then as those, you know, as kind of the difficulties pile on, maybe, and maybe they lose sight of the reason why they got into it. So I just try to help people, hey, remember why you actually got into this. Because, and I don't know about you guys, but I call it dusty book syndrome. Like I've got all these things that I want to learn about. I buy the book, you know, and then there it sits on my shelf. It collects dust. I pull it off like, you know, a year later, and I'm like, I open it up. I'm like, oh, this book is sweet. I can't wait to start reading this. And then it's like, you know, it's, you know, where your priorities are and stuff, all that kind of thing. So I try to get people away from the dusty book syndrome. I try to like really motivate people to do it. So I have these little motivational things throughout the course to, you know, make sure I'm bringing people back. But I think that doesn't totally answer your question, Dan. That is kind of where I start though with the mindset, because I personally think it's pretty important. But
so it sounds like a momentum thing almost too. Like you need to just kind of keep making small bits of progress, that kind of thing.
Yeah, absolutely. And that's what I think is good about the challenges. I try not to make them too difficult, but I also force people. It's not like a regurgitation of the lesson. Usually you have to like think a little, you know, you got to think on your own a bit. So, but
that, sorry, that's the difference between putting a course together and writing a tutorial. If you're writing a tutorial, you're putting a recipe together and you're telling somebody how to get from point A to point B. But if you're putting a course together, you have to demand of the person that's taking the course that they put the things that they're learning to practical use for themselves.
That is a very good distinction, Dan.
Thank you. I just came up with it. Copyrighted. Right.
All right, there we go. Yeah. So okay, so let's talk about some more of the practical and digging into that kind of stuff. I mean, so, you know, Dan, you had mentioned starting with Ohm's law. Yes or no? Is that
absolutely?
You should start with Ohm's law.
You absolutely. Well, I mean, you got to start with blinking an LED or something like that, but
Yeah.
you can't go more than 2 or 3 steps into electronics without knowing Ohm's law.
Yeah.
You just can't, because that's like trying to learn how to speak without knowing how to ask where the food is, where the beer is, and where the restroom is.
That's right. Yes.
You got to know these sort of basic things before you can branch out to doing anything of any particular snazzy interest. You've got to understand voltage and current and resistance.
Yeah, but so how do you? Okay, so we were talking about motivation. We're talking about momentum here. So maybe someone's not particularly mathy or doesn't want to just do equations, stuff like that. So what's a good exercise for making sure you understand that kind of thing?
I think the calculating the resistance you're going to need for different types of LEDs is exactly the sort of practical thing that requires Ohm's law.
Gotcha. Yep.
That you're going to blink the LED, but you got to understand what that resistor is doing there and why that resistor is the size that it is.
Yeah, that's a good one. And that was one example I was thinking of as well. But the problem with that then is explaining to someone what a drop is. And all of this stuff, like a lot of the stuff that I run into when I'm trying to explain it to someone, it's like, oh, well, it's just a voltage drop. And then you look at someone that you're trying to explain this to, and they're just kind of like glazed over because there's so much jargon as well. So
right, there is a ton. Yeah.
So how do you get past that stuff then? So when you're teaching or when people are learning more specifically, how do people start to learn these terms that are arguably they're a lot of times based on physics, right? Like a drop is based on potential voltage differences, like they're based on band gaps, all this stuff, like energy level higher and lower, that's the drop. So how do you do it without getting down into the physical level?
Right. Because it can all become a rabbit hole too, because you can quickly dive really deep into that stuff. And that's a great question.
I come at it from the standpoint of holes. As soon as anything I need to explain to someone starts talking about electrons and holes, that's where I stop.
Yeah, right.
Because you don't. I'm not trying to teach people that are going to go out and build semiconductors. I'm talking to guys that want to make large scale LED arrays blink rather than just 1 or 2, or they want to interface with a more complicated sensor with like an IMU or something like that, and they really need to understand the timing of it. Mm-hmm. But at some point you just got to stop and go, you know what, if you really want to understand that stuff, that's what Wikipedia is for.
Yeah, right. Okay.
Right. Yeah. And there's something to be said about kind of knowing something, because when you're just starting off, like you said, Chris, some of these concepts they're just kind of difficult to understand, or they're just, they're weird. It's not like, it's all just a rather amazing phenomenon, I think, personally.
Yeah.
And trying to wrap your head around that, some of the stuff just might be fuzzy, period. And I think at some point you kind of have to be comfortable with the fact that, like, okay, well, I think I get it enough.
Yeah.
And allow yourself, kind of let go of the fact that, okay, maybe I don't have this like 99.9%, but I think I have it enough that I can move on to the next step.
Yeah.
And then, that next step kind of, maybe that clears up some of the stuff that was vague before. And you just kind of
sit in the discomfortable position of the uncomfortable position, and like just kind of live with the discomfort rather.
Right.
Yeah. It's like another skill you need.
So you teach people how to use KiCad and how to design circuit boards, but you're not teaching them how to write KiCad.
Right. Yeah, that's a good point. Yeah, right.
You're definitely putting a stopping point on what it takes to design a circuit board, on what it takes to design electronics.
Yeah.
There's sort of an accepted starting point there.
Right. Or even, there's tons. Yeah, there's always levels of abstraction. That's one of them where it's just, okay, we're just going to deal with the circuit board. Sure. One example I was thinking of, Dan, is Dan did a thing where he broke down a lot of the different pieces of an Arduino, because it's kind of this common board that a lot of people know and stuff like that. And what was it? Was it the the ESR of a capacitor. Was that what you were working on? I remember you kept asking me questions about this stuff, and I was like, I don't know. And for me,
Yeah,
it was just I just ignored all this stuff, and you were going really deep, and that seems like another problem where you can, like the rabbit hole, like Michael mentioned.
Yeah, it was the output capacitor for the 3.3 volt regulator on the Arduino. I was looking at the data sheet and everything's fine, and then it gets into the how you spec the capacitor for the output, and it basically said, you can use ceramic capacitors for this. You don't have to go with a tantalum or an electrolytic or something like that, but you have to make sure that you match this specific ESR.
Yeah.
And I remember asking you, like, how do I calculate the ESR?
Which we should also say is equivalent series resistance, which is another
equivalence.
Yeah, right.
Yeah,
Sometimes
exactly.
it's an acronym. Sometimes it's we should know what it is. But yeah.
Yeah. So how do you actually calculate what the equivalent series resistance is going to be for this capacitor, but specifically in this application? Because the data sheet for the capacitor tells me that it's all frequency based, which makes sense. But the data sheet for the LDO didn't mention anything about frequency at all. It just said you have to be within this range of resistance and you'll be fine. And I think you told me something along the lines of just ignore it.
Yeah, exactly. Also, we should mention as well, LDO is low dropout.
Low
dropout
voltage
regulator. Usually they're LDO regulators, linear regulators.
Right.
Yeah.
And then I mentioned another word that I'm adding to my lexicon of places that I'll get to and stop trying to explain things, which was it poles?
Poles and
Like
zeros.
It was,
yeah,
poles and zeros. Yeah, poles and zeros and holes. These are three things that
right.
I'm
Full
putting
stop. Yep.
Yeah, I'm putting my foot I'm putting my stake in the ground right now, saying that I am choosing not to understand these things ever in my life. I don't see any reason to.
From my perspective, so I started, I know I mentioned on the show before, but I started electronics really in the academic setting and then kind of learned the other stuff later. And, there is, you think poles and zeros are hard when you actually have a use for them. When it's just math, I mean, like, I remember just being like, what? Why? Like, oh, yeah, if there's poles on the left side of the plane, left hand of the plane, then it oscillates and blah, 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 blah. And it's like, but who, what? Where is this? This isn't real to me. And like literally, it was just an equation. And that's kind of my background and why you need if you were going to dive into it, then you need the practical, right? You need to know, someone has to some point be like, this is important because blank. You got to find the why, right? And no one ever did that for me. So
would you say that there has been distinct value in your formal education in the world of electronics that you have found yourself in over the last 15 years?
That's hard to say, man, because I didn't do it the other way, right? I mean, I only can compare myself to people that went in the other direction. So I value my education in general, but I don't know. Yeah.
Because that's something that I'm curious about. If I had ever gone down the path of getting an EE, what would my experience be like now, as opposed to having, taught myself all this stuff myself?
Yeah.
And I run into things, and I imagine that this has got to be the same sort of thing that either my students or your students or Michael's students run into, is that you can have deep understanding of something and not have any idea that there's a blind spot just to your left.
Yeah.
Because you just couldn't know it.
Right. I think the thing is for a lot of this stuff, like, I think the reason that college programs got along so well for so long was that the kids that were going into EE were hams. They were doing stuff beforehand, right? And I was not that. I was not building stuff on my own. I didn't have any mentors that were getting me into electronics. And so they had that kind of that tribally learned knowledge, there was interest there. And then it's like, okay, now let's go learn the math. But there was that stuff beforehand. And I think that's still the case. The people that were in my programs that did really well often had that, and even talking to Dave had that as well. He had the the other stuff before he went to university and things like that to learn the math side of things. So if that's there, then yeah. But I think that then it's a question of, okay, well, what about the people that are just starting out, like someone in high school who's learning this stuff? Then what? Then that means that they're by definition not starting with the math either.
Would you
Right.
Would you
Yeah.
actively encourage somebody to go get their EE?
Sure, yeah, but figure out if you want to go first. That was the other problem, is that all the people in my program had like a 30% survival rate, just in general, because they tried to weed people out just with math, and that's a terrible way to weed people out. You weed people out with, do you care about electronics? Do you care about electrons and holes? And luckily I did. I mean, honestly, I was lucky that it kept being interesting, because a lot of people that might have eventually enjoyed it, they got scared off by the math, and that's the sad part. So yeah. Poles and zeros, man. Poles and zeros.
Which is funny, because how much math do you actually do on a daily basis?
No, if I do, it's usually using online calculators or something like that.
Exactly, yeah.
That's the other. Yeah. I don't know. I mean, like, Michael, is there any math on the Arduino side? I mean, programming usually has it, but
Right. Yeah. So, I mean, just regular Ohm's laws calculations and stuff, which is just basic, really basic math. That's as deep as I get into it. Just working through that type of thing. And I personally enjoy mathematics. So I think if you can approach, and I mean, this is kind of going off on a tangent here, but if you can approach the math and think of the math as like a tool, kind of frame it in your mind that way, then I think that can actually be kind of exciting, because you can really start doing some neat stuff, especially on the programming side. If you kind of embrace some of the math side of it, it's kind of fun. Yeah.
Yeah, well, the programming stuff too. I mean, so in terms of the stuff that I learned in university that, was put to me as, oh, you're going to need to know this specifically, like Laplace transforms, right? Oh, this makes solving RLC circuits much easier, circuits with resistors, inductors, and capacitors, right? And yes, it does, but Spice makes that even easier. And I'm not saying that you should start with Spice, but honestly, Spice is doing these approximations of Laplace transforms, and a lot of times it's important to know that stuff. But I can't say what it would be like without the base knowledge of that. But no employer where you're going to be, if you're thinking about doing this as an employment type thing, no one's going to wait for you to go solve your problem and redo it. Like, you need to learn it, but it's not really going to be useful on an everyday basis, because you just got to get stuff done. So, yeah.
Yeah, and I guess where it kind of comes in is, Chris, you having done that, when you go and you use, LT Spice, you kind of have an underlying knowledge there of what, maybe you don't know that it's been a while, you don't know that calculation exactly that's going on or whatever, but you have an underlying knowledge there that I wouldn't have using it. And so I feel like you would, having that education that you did have, you would have an advantage, because you might see where, well, maybe this is where I could, you'd know your limits of how to use it a little better, I guess. You see what I'm saying?
Yeah, no, I know what you mean. And I think that of all the things that have been most useful to me, I've talked about it on here before, like mantras, and so mantras were like things that that at Keithley, like the engineers there would be doing, so they would just be like, V equals LdI dt, right? That's right. I think that's right? So inductance is times the fast change in currents, right? So that's basically, that describes a ton of things, like how boost converters work, and that helps explain how relay kickbacks work, but it's really about internalizing what's happening in the physics, and I think that can happen before you dive into the math. And again, I'm coming at it from one direction, you guys are coming at it from another, but it's ultimately the everyday useful stuff is understanding when you see an inductor and you see, okay, if there's current going through that inductor and a switch shuts off somewhere, I'm going to have a voltage spike. That's explained by V equals LdI dt, right? Di dt being, changes in current quickly. So that, I mean, that's the important part. But
Well,
getting
you
to
know,
that
I
point
think
is there's a lot of paths there.
there's something very fundamental that I remember. It was almost a physical sensation when it clicked for me, was when I stopped thinking about electronics in terms of 9 volts and ground, or 12 volts and ground, and started thinking of it in terms of levels of potential.
Oh yeah, okay.
But no one taught that to me. I never read that anywhere. It wasn't covered in any book. It wasn't covered in a tutorial. There's certainly no instructable about it. It's just the way I think you start to evolve in your thinking about things.
Yeah.
When I started thinking that, it's not a matter of this capacity. I was just helping somebody today understand the reset circuit on the Arduino a little bit better, and I discovered that I was trying to explain it to him in terms of potential rather than in terms of voltages, and that it made more sense explaining it in that manner rather than the way I probably would have tried to explain it 5 or 6 years ago.
Yeah. So yeah, for me that was switching over to thinking everything is current. Like that was a big one for me because I used to think, oh well, what's the voltage here, what's the voltage there, but it's really about, well, if you have current flowing into a capacitor, right, you're going to see the voltage slowly rise. That's going to be, as the capacitor fills up with charge, because current's flowing into it, that's when your voltage rises. And before, the way I was taught it was, oh, well, voltage just changes over time. It's an integral, it's an integral. Yeah. And so you integrate charge. That's the math part of it. And it's like, well, sure, but what happens if I think about current moving to different parts of the circuit, or current flowing into the input to an op amp? Oh, no, it doesn't flow in there. Yeah, it does. I mean, there's leakage current there, but you're right, and this is kind of what Michael was saying too. It's like this is where the persistence is. It's just sticking with it until your brain just creates its own mental model, right? That's, you have to teach yourself.
Yeah, and I think probably everybody has a slightly different model of what of how they're understanding it and what's working best for them, given their how they got into electronics in the first place, and all those things.
Yeah.
So along those lines, I've been trying to think of what is the best way of approaching this entire thing. Like what path do you follow to get somebody actively engaged, both in the long run and in the short term, so that they keep coming back? Obviously, from a personal benefit, from the standpoint of they keep coming back and they keep buying boards or they keep consuming my content, but more philosophically, how do they keep coming back because they're interested in what it is that they're learning? And I've keyed on 3 things that I think all will wind up working hand in hand, and it's very fortunate that they all start with E, because then I can write a whole book now because I've come up with the 3 E's.
There's 3 sections. Here we go.
Yeah, exactly. Yeah.
Dan gives the outline.
So the first one is exploration, right? Is that you have to be interested in exploring the topic in the first place. But that's the getting lost down the rabbit hole of Wikipedia. That's your exploring. You're
like
learning
a joyful exploration almost, right?
Yeah, exactly.
Where you're excited about that.
You're learning new things. You're thinking of things that you never really thought of before, or you're thinking of things that you have previously thought of, but you're thinking of them in a new way. You're learning. Oh my God! Running a microcontroller is not outside the scope of things that I can possibly do. This is an approachable thing that can be a very powerful thing. But you're exploring. You're not really understanding it yet. You're just seeing what the bounds are of what these things are. So that's the first one. Then there's education. So you move from the exploration into the education. Now you've decided that this thing that you've explored is worth your time and effort and money, because we're all adults here, and it turns out you can learn anything you want, but chances are you got to pay to learn it.
Yeah, at least for the hardware and everything else, right?
Yeah, exactly.
Yeah, there's lots of free tutorials online, but yeah, learning hardware requires hardware.
Right. And but value and cost are it's not necessarily just cash, it's also time. I mean,
absolutely.
The time, sometimes you can, if you're willing to pay some money, you can you can devote 4 years and go to college and kind of be zoned in, or you can buy a course or you can spend a lot of other time just, I don't know, perusing.
Well,
if
right,
you know where I'm going.
Or in a very real example, you can choose that when you're done, managing storage array network all day, that you're going to go home and you're going to dedicate an hour and a half or 2 hours of your life to watching Chris's videos on how to design electronics, because that was important to me. I wanted to learn how to use KiCad. I wanted to learn how to design circuit boards. So you make not just the investment in money, but for all of us, it's the investment in time that's even more critical at that point.
Right.
So
Yep,
the third
absolutely.
E is ears, right? So you have to avail your ears and listen to Chris talk about KiCad for a couple hours.
No, the third E is enjoyment. Is that so you explored this topic, you've educated yourself, you've learned something about it. Well, you've gone through all this effort. Now you've got to enjoy it. You've got to go do those things that you are now capable of doing. Right.
Yeah.
So those are the three things that I am particularly want to focus on.
I have another E in there that's actually pretty important.
What's that?
Explosion. Like
Explosion.
like honestly, like that's a big part. Like I want people to be safe, but like at some point you're going to be like, all right, it's time to turn on the power supply, and this might go puff, right? I mean, it might pop some caps, and or you might not even be prepared to say that. You're just saying it's turning on the power supply, and then it does go puff, and it's like, but that's important too.
That's interesting, actually. That would be an interesting thing to put together, is a circuit board that's designed to fail, but
I like that. Yeah,
but you teach people how to troubleshoot what failed.
I like that.
That's
Too,
yeah, that's kind of a neat idea. Yeah.
yeah, I mean, troubleshooting is a huge piece of it. But you don't.
Dan, is that what you're going to say when you build a board that fails? Like, oh, actually, I did that on purpose. That's a great strategy.
Yeah, that's what I did. Yeah. There was a footprint that was wrong on the first contextual electronics board that was a soldering practice thing. Dan remembers. Yeah.
That's exactly what I was thinking.
Yeah. Yeah.
Yeah. And you were going to teach us how to use Bodge wires too. That's why you decided not to include the oscillator. That oscillator. Yeah.
Yeah. You know what?
And boy, did I learn.
Yeah. But it is important, right? I mean, like, not that I wanted.
That's what it's really about.
Not that I wanted to mess it up. It's just that you're going to.
Absolutely.
Yeah.
That was honestly some of the best experience was figuring out, because I designed my own bench buddy alongside the bench buddy that came with the class. So when it came time to get that oscillator on there, my board was completely different from the board that all the other students were using. And I had to sit there and figure out myself, how am I going to get this thing soldered down? Because all my footprints were entirely in different locations. So trying to find those pads was significantly tricky.
Yeah. What about, so we kind of got away from the rabbit hole, but I think that's actually really important. So, like, understanding what you need to know. What do you guys think about that? Like, how do you decide if you should go down the rabbit hole, if you should go to the Wikipedia hole, or if you should just kind of scuttle through it? You know what I mean? Like, scuttle past it, I suppose.
Yeah, I guess part of it depends on the context of, why you're learning in the first place. So if, I was helping a guy out the other day who was doing this art demonstration, Ingenuity Fest up in Cleveland.
Oh, yeah, yep.
He was doing a demonstration up there, and he wanted to have this like capacitive touch thing with his art display, and he reached out to me and asked for some help. Anyway, so he kind of knew some about electronics and knew some stuff about programming, but I mean, his real goal, he just wanted this thing up and running, and he wanted me to assist him with it, kind of show him what needed to happen. So for him, the rabbit holes didn't mean too much. He just needed to get to an end point, really. But if kind of back to the E's, if you really enjoy it and you like that exploration, then I think it just matters how much time you have on your hands. I personally love just, I don't know, learning about stuff, spending a lot of time learning about stuff, even if I don't necessarily need to do it. But
yeah, so you're willing to push out the date of when something finishes just because you want to enjoy the time around that.
Right. Yeah. And I guess it just matters again, what is your real goal? Like, people taking my course, for example, is their goal to just hit complete on the last lesson, or is their goal to say, or like, okay, I want to finish this in 3 months, or I want to finish this in 6 months, or do they want to say, I don't really care when I finish this. I want to transform what I know internally, and it doesn't really matter how long it's going to take me, kind of thing.
Mm-hmm.
I don't know.
Yeah, I mean, it's tough too, because people always ask me kind of like what books should I have, right? And of course, I always recommend The Art of Electronics, but then I kind of pause usually, and I'm like, but don't try and read front to back. Like, use the table of contents and just one at a time, man. Just one thing at a time, or just browse the stupid circuits. The part of the book I'm talking about there, the don't do this circuits.
I don't actually have a copy.
Oh no, yeah. It's like in sections like 3 and 4, 2, 3, and 4, and maybe even later because it's changed around with the third edition. But he it's like specifically for op amps. There's a section where it's like it's just 2 or 3 pages of bad circuits. Like he says, do not do this. He doesn't say anything. They don't say anything else about it, and it's great. And it's like you're looking at it like, well, I could do that, and you can, but it's not smart. And that's kind of the idea, where you just kind of look at it and you noodle on it, and then you go read, you come back, and you leave the book for a while, you come back, and you're like, oh, that's a terrible idea, and now I know why. And yeah, where do you guys go for your resources? I mean, where do you guys find stuff online or in books or whatever?
Hackaday.io chat.
Oh yeah.
Yeah, I contact this dude named Chris Gamble.
Oh, that doesn't count.
Well, actually, that kind of counts a little bit, because for me, I have a mentor. Like I consider him an electronics mentor,
Uh-huh.
and he's not quite gray haired, but he's getting pretty close. And oh my gosh, it is just the most amazing asset to have somebody who's personable, who you can ask questions that you don't even know how to ask the question on Google. You don't even really understand what you need to ask. But I'd known the gentleman for a while. We actually worked together, but I didn't know until about 3 years ago that he actually owns an electronics company. He does embedded stuff
cool.
for a living.
Yeah.
And so I mean, I can call him all the time and just kind of explain what I'm thinking in my head, and it can be like, nope, you're totally wrong, Mike. And he can be frank like that, and he can be like, and to boot, he's a really good teacher too. He explains things well. But man, I love that. And also, so I mean, that's kind of a step away from books and online media.
No, but
because you're actually
great,
interacting
with
it.
That is really great.
And then also I really like, you and I are both involved in that electronics meetup. And I mean, I enjoy going, and I usually learn something when I go. And so I think that's really nice too, just to be able to kind of bounce some of those thoughts and questions off of people.
Yeah, like a social group where you can kind of and well, like Dan mentioned too, there is online stuff where you can get even just like a chat based, like there's like the hacker chat on Hackaday.io, but there's other stuff like that. There's IRC stuff like that where some people are going to be sitting in there and just kind of helping people out, and even having it as an IRC versus having it as a a message board, it's different. It is a little bit, it's a step closer to the personal side of things.
Yeah.
I try to be relatively active inside the Arduino subreddit on Reddit.
Yeah.
Because that's where a lot of people come with those. They ask the same questions over and over and over again.
Right.
And if you go into the forums on the Arduino.cc website, there is some seriously virulent people in there that are ready to smack you down for not searching the forum or something like that. You know what? Everybody just needs to lay the hell off. Just chill out.
Yeah.
Isn't that kind of forum in general though?
Yeah.
I think forums in general can be pretty.
Forums are definitely power structured, or power distributions rather. There's always super users, and then there's like long tail users that are just, I have one question every once in a while, and like you said, if you ask the same thing someone else has, God forbid.
Yeah, God forbid that somebody should ask a question and want information. I mean, oh my God, he wants to learn something. How horrible that he wants to learn the same thing this other person did.
Yeah.
So I try to be active in there and help other people out if I see something that I know I'm able to help them with. But for myself, I think I mentioned on embedded.fm that I've got this theory now that my level of understanding for something is inversely proportional to the amount of browser tabs that I have open trying to explain it to me.
Right. Yep.
And I don't think there's actually been any topic that I haven't managed to find a way to explain to myself or find some resource that will teach it to me. Other than, well, I take that back. That whole ESR thing for the capacitor, I never really got an answer to. What I did wind up doing was just ignoring it. I was like,
which was the great advice that you had, right?
Which was the advice I got at the very beginning. And if only I'd listened, I could have saved myself so many hours.
Yep. No, I mean, but there's still value in going down that rabbit hole and trying to figure that stuff out, right? You probably found out a lot of other stuff about capacitors and even just how data sheets are written, that kind of thing.
Absolutely. Yeah.
Yeah. I mean, you learn a lot of serendipitous information that might in fact help you out a lot later, but you just wouldn't know it in the first place.
Right. Yep. I don't know. I think the toughest part is when you, like Michael said, when you don't know what it is. That's when you don't know what you're actually asking. That's usually the hard part. So that's why I like an IRC where you can kind of like keep pinging and just like, well, is it this or this or this? Like it kind of looks like this thing that I've seen before. I don't know.
One of the best pieces of advice that I ever got from you, Chris, was to look for, like, you search for a specific topic. Like I'm looking for a LiPo battery charger circuit right now.
Mm-hmm.
And I've completely ignored anything that is text-based on Google now, and I go straight to image search.
Oh, yeah. That's fantastic, right?
Like, if I'm searching for a part number, throw that into Google. I don't care what anybody wrote about it. I want to know if you published a schematic.
Right.
And then I'll go straight to that right there.
Yep.
And that tends to be the way that I'm solving a lot of problems right now. Like this thing, I'm trying to pull this El Cheapo battery charger apart, and it's got some weird no-name brand device marking on there, and I'm just I'm going into Google and I'm searching not for a manufacturer name or a part number. I'm searching for charge controller in a SOT 23.5 and show me any schematic that's tagged like that.
Oh yeah. And any luck? No, nothing.
No, this is a total mystery part.
Well, that's tough too when you. Yeah, I think I saw you tweeted about searching by package code or package. Yeah. But like on a SOT 23-5, you can't really fit a lot of letters on there.
Well, and the thing that's killing me is that the package marking on this particular SOT 23-5 is 50T I think like 513. So I kept looking at it going, did they just literally call this part SOT-513? Like it's just a bogus part. They just soldered down so that they could use the footprint. Yeah, exactly.
Yeah. Yeah, that's tough too. And that's another thing that I think a lot of people come in with. So just kind of thinking about the no-name parts, stuff like that. Another thing that I struggled with when I was getting started was thinking everything is this super cheap, like Chinese level of, like if you start with electronics and you're like, oh, well, I'm going to open up a toy and think that I'm going to understand that. Well, like that's a super cost optimized thing where they're ripping caps off the board and there's not a lot of educational meat there. Versus if you find something that's a little bit more expensive, you might be able to find replicated app note circuit, something like that. And then that's where you're going to really find the useful information,
Well, I think that's you can definitely find the more reliable theory if you pull apart a more expensive product. But if you pull that cheap stuff apart that's designed to work 4 or 5 times, you can learn about how to make something just work.
Once.
Exactly. Like, I need to get this to work. And who knew that you could use a resistor in that way? Like they didn't decide to actually use it as a resistor. They just soldered it on edge to provide like a physical balance so that this pot doesn't wiggle around.
Oh yeah, I've seen that before. Yeah.
Yeah, that sort of weird stuff is the sort of stuff you'll find in that cheaper that sort of commodity level electronics.
So thinking about manufacturing, thinking about building circuits, stuff like that, when do you guys suggest that people start building their own circuits, branching out from a kit or branching out from maybe even just a dev board that someone else built and you bought? When is it time to jump out of the nest?
That's a good question. It might just depend on each, on people's situation, but I would definitely say that it is worth doing, and taking that leap and learning that stuff.
Well, I'd say there is value. There is inherent value in taking a circuit that you have on a breadboard, even if it's just a Larson scanner with a 595 shift register, and transferring that to a soldered project, like just a piece of perf board, and figuring out how to make those connections happen on the perf board, because you're not going to do it right. You're going to make mistakes. And when you make mistakes, that's when you're teaching yourself, is when you're troubleshooting that. I think
those are pretty low cost mistakes because you can fix it with solder and extra wire and stuff, right?
Exactly, and the series of components that you're using are probably maybe $5 worth, and you didn't have to spend $5 per square inch to get a board from Osh Park. Although where does anybody go to buy perf board nowadays? Like, where would you go in Cleveland to buy perf board? I would go to Fry's here in Yolo County, but
we have Micro Center up in a little bit north of me. And they carry a lot of kits and stuff now. But even still, I wouldn't do. I'd go online. I'd go go to DigiKey or Mauser or something.
Right.
Man, I don't. For some reason, I just can't bring myself to do that. That even with Amazon Prime, I refuse to wait 48 hours to receive anything.
Oh.
Like if I want perf board, I want perf board now, and I want to be soldering by the end of the day. So I'll drive 45 minutes to Sacramento to go buy a $5 stupid perf board that I probably won't have time to play with anyway.
Especially once you figure in California traffic, then it's like you should have just had it on Amazon Prime.
Well, Dan's in the middle of nowhere, so that helps.
Exactly. My 45 minutes to Sacramento is 45 minutes with a lead foot on the accelerator.
Yeah, it's 45 miles.
Yeah, exactly. There is nothing between me and Sacramento except for, I think, wheat fields, rice paddies, and Davis, California. So that's pretty much it.
Yeah. It's I think that brings up a good point too, of having that physical store. When we talk about mentors as well, you could be a place to find a mentor as well. Maybe just someone to chat with and ask a silly question or two too. That can help, but not everybody has that. I mean, it's not like surplus stores are what they once were, so that kind of hurts.
Yeah, like you could ever even go into a Radio Shack and ask a question.
Well, first step is finding one, and then second step is finding one with a knowledgeable staff person.
They might know the SKUs.
Well, yeah, you probably know where the parts are better than they do sometimes.
Oh, are you kidding? I've spent time in the Radio Shack in Hollywood when I was living there, resorting out their passives bin.
Right.
That's probably a remarkably embarrassing admission.
No way, man. You were public service.
I was performing a public service, exactly.
Service.
Right, yeah.
If I ever get arrested, that's what I'm going to ask my public service to be, to go to Fry's and sort out all their damn
blister pack
kits.
resistors.
Yeah. Oh.
Yeah. So let's get to the last of it then. So someone is listening and hasn't picked up. So they're listening. They're a casual listener, but they're ready. They're now inspired based on what you guys have said. What do they go online or go out and buy right now and start doing? We could say Michael's course or Dan's board, but let's step outside of that. What is the thing that they should buy and go for?
All right. So they're interested in electronics. They want to get into electronics specifically, or they want to get into, electronics is such a broad, are they interested in like microcontrollers, or they?
Well, let's just say electronics in general. Step one is...
I think soldering is a good place to start. It's not sexy per se, but I don't know. I think soldering is a good entry point.
So soldering what though?
Yeah, I mean, well, like a kit probably. Just learn to solder kit and that's not, I mean, because a soldering iron, a cheap soldering iron is cheap, and get just one of those soldering kits, and I think that's a fun place to start. It's kind of like a physical thing, so you got your hands on it. And,
Yeah.
I don't know.
Okay.
Dan, what do you think?
Well, I think that there's a pothole waiting for the prospective student that wants to start learning this stuff. In that, if you don't have a clear goal in mind, it's hard to know what to do once you get to an ending point. Like, okay, so I've soldered this thing. Well, now what? I think if you have something like an Arduino or a Raspberry Pi or BeagleBone, something that provides a basic entry point, but upon which you can expand, I think that is particularly valuable. Before Arduinos existed, I think going down the kit route would have been incredibly valuable, because then you get your hands on all these different passives and the analog side of stuff. But I mean, I look at my own desk right now, and I don't have the room or the time for that necessarily. But I've always got room for one more little USB device to sit on my desk that can make an LED blink. And like Alicia says with Embedded.fm, that the blinking LED is the hello world of electronics.
Right, yep.
Right.
So if you want to learn electronics, I would highly recommend finding something that's going to either make a motor move or is going to make an LED blink. Like, you want to see the electrons that you're controlling change something in the physical world.
Okay.
That's the magic right there.
So I think that one thing that we're going to see a surge of new people coming in, just because there's the $5 Raspberry Pi Zero was just released. And I think that's kind of the price point where it's like, oh, yeah, I'll buy one just because, that's like the tack on thing. It's like, yeah, why wouldn't you? So I think that'll be interesting. And then projects. So you're saying, like, if you had a Raspberry Pi Zero, you get a header breakout, or you make a header breakout, and then you tie it to some LEDs and just solder that together, write some code or find some code and get those blinking.
And I would hope that there are any number of tutorials that would be out there to help you get to that point. Right? That's the exploration part. You're not looking for the, like, I want to turn it on, and now I'm going to learn how to, do X and then Y and then Z. No, to hell with that. I want to turn it on, and I want to make something happen.
Okay. So you're saying, first step is buy the $5 board, buy the $20 kit that goes with it. Irony.
And do something fun with it.
Yeah, right.
Do something cool with it. And then if that fires your imagination, then and you're the sort of person that's inclined to do that, and I would imagine that chances are, if you're a listener to the Amp Hour, you're the sort of person that would be inclined to want to know why it's doing the thing that it's doing, not just being comfortable with the fact that it does something when you tell it to do it.
It's not just the finished product that you're buying. You're buying the experience along the way.
Yeah, exactly.
I've been saying this phrase a lot lately, but it's definitely not my phrase. It's how do you eat an elephant?
One bite at a time.
One bite at a time, man. That's what a lot of this stuff is, like that's just the.
Yeah, absolutely. And maybe it doesn't matter where you start, but that you just in fact start.
Yeah.
You just in fact take a step, get something going.
Yes.
Well, I think
that's what's important.
That's what you were getting at when you were talking about mindset, Michael, is that the important thing is to want to do it in the first place.
Right.
And I mean, I think one of my big stumbling blocks when I was getting started too, it's like, oh, well, I need to create something unique and my own. It's like, no. At the beginning, it's okay. It's okay to buy a kit, or it's okay to copy someone else's circuit. It's okay you're going to find so many pitfalls along the way just doing a kit and just making sure you have the right parts in the right place and the right diodes in the right direction kind of stuff. Or, just don't worry about being unique. Just get something hands-on, and I think that's gonna take you pretty far.
Yeah, I mean, it's like you have that great idea or whatever, and then it's not like the internet doesn't already have that idea. So it's like that can sometimes feel a little demotivating, but it shouldn't, because it's, you, like you were just saying, Chris, you learned so much just doing the things.
Yeah.
It doesn't matter if it's been done 1,000 times by 1,000 other people. You're going to learn a ton kind of going through it yourself.
Mm-hmm. Yeah, and then eventually it's also it's like music too, right? You start out, you learn, if you're learning piano, you don't start by trying to compose a piece. You start by learning Bach, or something simple, simplified versions, and you kind of work your way up, and then eventually you start to modify, and you start to play on different themes, and you try different things, and you piece together different sounds that you've heard, and then eventually you start to, if you wanted to, then you can create your own sound. But you don't start just, well, some people do, but it sounds terrible. You're not gonna last long, in my opinion, if you're just banging on the keys. It's a lot more fun if you take some time, follow some other people's footsteps, and then start to play on the different themes. And it's important that, so I'm obviously playing piano right now and learning, but it's important to have that bass line, and then, it feels good to play a song, to have that finished song where it's like, oh, someone else listens, they're like, is that a song? Is that, Moonlight Sonata? I know what that song is. And you say, yes, I played that song. It's not like someone's like, oh, well, you didn't write it.
Right.
Way to go, genius. Call me when you've created a classic piece of piano music that is played all over the world.
Oh man, that's brilliant. That's exactly what I would want to say to every person that was criticizing that poor kid about not having actually built the clock himself.
Yeah.
He's not building a clock. Come on, give him a break.
Yeah. Yeah. That story didn't turn out as well as I hoped it would.
No.
but now that they're suing the school, I don't know. Anyway, I don't want to talk about it. But yeah. But I agree with the sentiment where it's like, yeah, if you're criticizing for that piece of it, it's like, come on. Yeah. So, what is your Moonlight Sonata, Michael and Dan? What are you guys working on next? Because we should probably wrap up here soon.
Well, like I mentioned earlier, I'm working on I'm just really working on the second edition of my course. So that's what I'm up to lately. A lot of shooting video, a lot of thinking deeply about curriculum and that type of thing. So that's what I've really been up to lately.
Nice.
And I'm really focusing on the sort of the education and the enjoyment aspect right now. I'm pushing a little bit into the electronics basics with a sort of a basics education shield. But I'm also putting together a board that is a little desktop graphic equalizer display, like little, dancing lights to the music sort of thing.
Oh, nice. Yeah.
But probably the coolest thing, and I just got the boards back maybe half an hour before we started recording. I put together this thing that I'm calling the Snowbot, which is a little ornament. Although it's going to have a lithium polymer battery on the back of it, so I don't necessarily recommend hanging this inside a very dry Christmas tree.
Christmas vacation style with the tree going up.
Yeah, exactly. But it's a PCB of an octagonal snowman with a Larson scanner for an eye and a potentiometer for a nose, and detachable arms that you can solder in place. And hopefully a boost converter on the back that's going to work beautifully. And then you will have your own personal little Snowbot. And what I'm going to do is I'm actually going to give this design away with the bomb so that anybody can build this themselves if they want to. But I just got to make sure the boost converter works first.
That's good. Yeah.
That's cool.
Yeah. That's great. And we'll maybe post pictures of it. If there's a preview, we can do that.
Yeah, absolutely.
Awesome. Yeah, and we'll definitely post links to Michael's course, to Dan's tutorials. But thanks, guys. Any last thoughts for the show, for the audience?
No, I can't. Just thanks again for having me on. It's exciting to be on the show.
Yeah, and I'm really grateful to have this chance to talk to your audience. The only thing I would want to add is what I told Alicia's audience, is that don't be scared of this stuff. You know, if you're going to fry something, go ahead and fry it. I mean, so you destroy a $5 microcontroller. Go get another
it's
one.
not getting more expensive, right?
Yeah, exactly. Right. You know, don't allow yourself to be intimidated by this stuff. Some of it is truly difficult. Some of the stuff is going to require you to be very diligent and very intelligent about the way that you approach it. But the reward that you're going to get, the way you're going to feel having actually learned some of this stuff, is going to be very, very, very gratifying and potentially very rewarding in other ways.
You get to make Snowman Larson Scanner ornaments.
Absolutely.
So,
there you go.
How cool is that?
Awesome. All right, guys. Thanks again. We'll talk to you soon.
Cool. See you, Chris.
Bye.
When I first got into electronics, I did it out of necessity. I had to solder something in my car.
Oh, yeah, right.
And I had no idea to solder, so I had my next door neighbor do it. And apparently he didn't have that much experience either.
And my car burned down.
Well, actually, the car started smoking. We had put the electrolytic capacitor on backwards in this transmission computer.
Yeah, that story might go in the outro.